Hello, welcome to Electronics Education. This is Vincent Chang. In this lecture, we are going to continue our learning around operational amplifier circuits. Operational amplifier circuits. Inverting operational amplifier circuits, part 2. We are going to investigate the effect of finite open loop gain on the inverting amplifier. The effect of finite open loop gain on the inverting amplifier. So in the previous lecture, we have studied the characteristic of this inverting operational amplifier, assuming the op-amp, the operational amplifier, is ideal, which means the open loop gain A is infinite. When the open loop gain A is infinite, in this type of negative feedback op-amp circuit, there's an interesting phenomenon called virtual short circuit between the two input terminals. So based on the closed loop analysis, the closed loop gain A, which is defined as the VO, the output voltage, divided by the input voltage, will be equal to negative the R2 over R1. And the input resistance of this inverting amplifier is determined by the input resistor, which is R1. So there is the trade-off between the input resistance and the closed loop gain. In this lecture, we're going to investigate the effect of finite open loop gain, the open loop gain of the op-amp is finite. And so how to conduct the closed loop analysis in this type of scenario. So in this situation, let me give you let's say 5 minutes. Try to figure this out. When A is not infinite, let's say if the A is, let's say 10,000 or 100,000, 80 decibel or 100 decibel. So what's the closed loop gain? VO divided by VI. Let's pause for 5 minutes. The main purpose of this lecture is to investigate the effect of finite open loop gain on the inverting amplifier. First, I will recommend you try to find out the voltage of the inverting terminal, which is VB, the voltage of the inverting terminal. Because when A is finite, which means the virtual ground is broken, so you cannot apply the virtual ground anymore. So if VB is not grounded, so what's the voltage of VB? What's the voltage of the inverting terminal? So remember the ideal model, right? The voltage control voltage source. VO equals A times the difference of the A and the B. Now the A is grounded. 0 minus VB times A equals VO. When A is finite, then the VB equals negative VO divided by A. So let's plug in this. VB equals negative VO over A. You can get the current I1. The red current I1 will be VI minus subtract VB divided by R1, right? So therefore, the VO, the output voltage, will equal to what? Equals to the inverting terminal, the VB minus the drop. Deduct the I1 times R2. So you can plug in the I1. Again, what is the I1? The red current. The difference between VI and the VB, and then divided by R1. And the VB is negative VO over A. The I1 is this. I1 is this. So now if you look at this equation, on the left-hand side of this equation, there's a VO. On the right-hand side, 2 VO and 1 VI. So you can try to find out, you can find out the closed loop gain VO divided by VI over VI. So here's the answer. All right? So this is the answer. So if you look carefully on this, the numerator of this closed loop gain is the ideal term. Remember, in the ideal case, the closed loop gain A is what? The closed loop gain is not A, sorry. The closed loop gain G equals negative R2 over R1, right? So the highlight part, the red highlight is the error term, is the effect. So what's the effect? What's the effect of finite open loop? What's the effect of the finite open loop gain on this inverting amplifier? So this is the effect. The red highlight is the effect. So when A is not infinite, the closed loop gain G will be upgrade or downgrade, will be downgraded. But when A is go up to the infinite, if we increase the A, the error term will goes down, right? But if you A reach to the infinite, then the error term will vanish, and you will go back to the ideal case. All right, this is the takeaway. So again, the purpose of this lecture is to investigate the effect of finite open loop gain A on the closed loop inverting amplifier configuration. And the effect, what's the effect? The red highlight, the red error term. So this is the end of the lecture. I hope you learned something from this lecture. Thanks for watching.